Today we're doing the third set of notes and we're going to be talking about graphing in standard form and multiplying binomials. So the first thing we need to discuss is standard form, and standard form looks like f of x equals ax squared plus bx plus c. One of the things that's important to know about standard form is that your c value is always going to be your y-intercept. So vertex form shows us the vertex, and that's what we talked about in the lesson prior. Standard form is going to show your y-intercept. Notice there's no parentheses involved in this form, and you have three individual terms. So when we are in standard form, the formula I will have to use is negative b over 2i. And once I get that numerical value, I'm going to take that number and plug it in to find the y value. So you're going to plug that in to find the y value. Axis of symmetry always goes through the x part of the vertex. So again, if I want to know the axis of symmetry and I'm in standard form, I would just do the calculation of negative b over 2i. As far as the process goes, it's very similar to yesterday's lesson. So step 1 is find the vertex by doing x equals negative b over 2a. Step 2, make a table. Put vertex in the middle. Step 3, pick two x values on either side of the vertex. So two bigger, two smaller. And you're going to plug those in. And then step 4 is going to be plot your points. So as far as the examples go, I'm going to do letter B and D on your page, and you're going to try A and C as practice. So again, we're going to identify what A, B, and C are first. So A is always in front of your x squared. So I have a 1x squared, so A is 1. I have a negative 6 in front of my x value, and 5 is my c value. So again, in terms of what we know the y-intercept is going to be equal to 5. So if you want to jot that down, that this is your y-intercept. Now I'm going to find the vertex by doing negative b over 2a, and you just got to plug the values in. So I have negative of a negative 6 over 2 times my a value. Negative of a negative 6 becomes positive 6 over 2, which will just be 3. So in terms of my table, I know the x part of the vertex is located at 3. Now I need to take that 3 and plug it in. So I'm going to do 3 squared minus 6 times 3 plus 5. You are welcome to use a calculator to make that part go faster. So 9 minus 18 plus 5, which will be negative 9 plus 5, which is going to equal negative 4. Now I have my vertex, and now I'm going to pick two x values on either side. So I have a 1, 2, and a 4, 5. I'm going to pause the video, and I'm going to do the rest of the calculations. I would like you to do the same, and then hit resume once you have found the other two values. So notice again, you don't have to find every single value. You only had to really plug in like 1 or 2 or 3 or 4 or 5. So those y values repeat and the other y values repeat, because once we know where the vertex is, all the y values repeat on either side. So now that I have these values, I'm going to go ahead and plot them. So I have a 1, 0, a 2, negative 3, a 3, negative 4, and again, my axis of symmetry is happening at x equals 3, because that's what we got for the x part of the vertex. So I can just reflect these points over. The one other point that we know is the y-intercept of 5. So I can add that to my picture. That's crossing the y-axis at 5, and if I reflect that over, it will reflect to be right there. And now you have your quadratic function. So now we're going to drop down, and I would like to try letter D next. Again, making my list of A, B, and C. A is -1, B is -2, C is 1. That's my y-intercept right there. And now we're going to do -b over 2a. So I have negative of a -2 over 2 times -1. In the numerator we get 2, denominator -2. So the x part of the vertex is going to be -1. Now I need to take that -1 and substitute it back in everywhere I see x. So notice I get myself set up with the parentheses, and the value that I'm substituting in is a -1. Going through our order of operations, or you may use a calculator, when I square the -1, I get +1, but there's still a negative out front, so it turns it back to being negative. Then I have +2 in the middle and a +1. The 1s will cancel, and I'm left with 2. So for my table, my vertex is at -1, 2. The two other values that I'm going to plug in are going to be -2, -3, and a 0, 1. Again, I'm going to pause the video, go ahead and fill in your table, and then hit resume once you are done. So to plot my points, I have a -3, -2, -2, 1, a -1, 2, and again, I've now hit my axis of symmetry, so I know all my points are going to reflect on either side of this, and I have 0, 1, and I have a 1, -2. Now this time when I go to add the y-intercept, it already is on there. The coordinate 0, 1 is already there, so I don't have any extra points to add to my picture. Notice that this quadratic is opening down because the a value is negative. So whatever the a value is determines the direction in which it opens. Because it is opening down, we would say that my vertex is a max. So this point right here is the highest point. If I ask you what the max value is, you would say 2, which is the y part of the vertex. So you are now going to try A and D as practice, and that's what you're going to show me next time I see you, or answer the questions if it prompts you to answer a question in the video. One thing I do want you to be cautious of is that for letter A, your B value is going to be 0 because you're missing a term. And for letter D, this is how you're going to scale your graph, because your vertex is going to be, the y value is going to be fairly large, so you're going to scale your y-axis by 2s. So next thing we're going to discuss is multiplying binomials. So I'm going to show you 3 different methods, and you decide which method you like the best. So the first method is called FOIL, which stands for first, outer, inner, and last. So we are going to connect our terms with following those directions. So I have a 3x plus 1 and an x minus 5. So let's go through and just do the connections part of it. So first means I'm going to connect to the 2 first terms. When I do that, I get 3x squared. Now I'm going to connect the 2 outer terms, which will be minus 15x. Again, we are multiplying. I stands for inner, so I connect the inner. And L stands for last, which will be negative 5. Make sure you multiply. And now you just combine like terms, and when I do that, I get minus 14x for the middle, and nothing combines with the first and the last. So that's the FOIL method. I'm going to show you 2 more methods. So the other 2 methods, the next one is called the box method. So you're literally going to draw a box. We're going to draw a 2x2 box because I have 2 terms, and each term has 2 values in it. And now you're just going to find the area of the box. So I have a 3x squared for my top box, 1x for the top right, a negative 15x for the bottom left, and a negative 5 for the bottom right. And again, we go to combine like terms. For the box method, people, your like terms are always going to appear on the diagonal right there. So again, I get 3x squared minus 14x minus 5. Just make sure you don't get multiplying crazy. You are now adding after you do that first step of multiplying. And then my last method is the distributing method. I would say this is probably the least popular, but I will still show you just in case it resonates with one of you. So distributing people, you're going to take that first binomial and you're going to cut it in half. And you're going to write the 3x, and then I'm going to write the positive 1. And I'm going to leave a space. And now I'm going to give them each that second binomial of the x minus 5. This is called the distributing method because once I split it up like this, then I just go through and I do a series of distributing. So I get 3x squared minus 15x plus x minus 5. So I get 3x squared minus 14x minus 5. Again, you need to decide one of the methods that you like the best and go ahead and try it. So you have several problems on the rest of the page to try, so determine kind of which method you want to try and go for it. Last thing I want to talk about is on the very last page of the notes, and this is converting from any form into standard form. So again, this is vertex form. So we want to convert this to standard form. So to do that, I'm going to take this binomial right here, and I'm going to be writing it twice. Because it says it's squared, I'm going to do x minus 2 and x minus 2. When something's squared, that means there's 2 of them. So I'm going to go ahead and FOIL. If you like the box method, draw the box, put these on the outside. You get x squared minus 2x minus 2x plus 4. And when I combine like terms, I get x squared minus 4x plus 4. And now I'm going to go back to the original problem, and there was a 2 out front, and there's a plus 5 on the end. So now what I need to do is distribute this 2 into the 3 terms that are next to it in parentheses. And then now I can drop the parentheses, and I still have that plus 5 hanging around the end. And now my final answer is 2x squared minus 8x plus 13. So in terms of things that we know, I know the vertex is at 2, 5, and that's coming from opposite seam. I know the y-intercept is going to be happening at 13 because now I'm in standard form. So different forms show you different things. One last problem, and I know this is a long lesson. This is what we call factored form, and we'll talk about this in the next lesson. So this is factored form, and the factored form shows you your x-intercepts. And we'll kind of, again, talk about that in the next lesson. So we're going to take this, and we are going to multiply it. So this time I'm going to do the box method. If you FOIL, go ahead and FOIL. And you're going to find the inside. So I have x squared, a 1x, a negative 3x, and a negative 3. So when I combine like terms, I get x squared minus 2x minus 3. And then I'll distribute the 2. So I get 2x squared minus 4x minus 6. And because I'm now in standard form, I know the y-intercept is going to be happening at negative 6. Disregard the graphs that are on that page. I do eventually go into graphing, but this is a long video, so we're going to pause there for today.